I just want to welcome everybody. Hello, and welcome to the first Sound Studies Institute lecture of the 2021-22 year. We're really excited to be back with another year of great talks and workshops and performances and exhibitions. We have some plans, we'll tell you more, but we're happy to be back. And we're coming to you, of course, from Amskewache-Waskahagan, sometimes known as Edmonton, Alberta. We're in Treaty 6 territory, which is the traditional homeland of the Cree, Blackfoot, Métis, Nakota Sioux, Iroquois, Dene, Ojibwe, Inuit, and many other Indigenous people. Sound and music have been heard and created and celebrated here for thousands of years by many cultures and nations. And tonight we were humbly here to add our sounds to this history with respect and solidarity. And if you're here for the first time and don't know anything about SSI, the Sound Studies Institute is a research institute at the University of Alberta that celebrates and supports research into sound from all angles, including performances and artistic understandings of sound, i.e. music, for example, but also other human and non-human understandings of the role of sound in our world. And so tonight we're really excited to bring you John Acorn and Yelena Reimer, who will talk to us about some mysterious underwater bug sounds. As a bug lover myself, I took this occasion, in fact, to wear my Magic Cicada Septendicum cap, which is in honor of this last year's the Brood 19 cicadas out in the northeast of the United States. Jen Mesh and I and lots of other people that I know were able to experience them the last time, and we were very sad that we couldn't travel to see the offspring of our lovely cousins that we spent so much time with back when I lived in New Jersey 17 years ago. So we were sad to miss them, but I heard great things. And so that's my little connection to bug sounds, and I'm very, very excited to hear more from John and Yelena. So I will turn this over now to John, and I believe that John will start, and then Yelena will finish up the talk. So thanks, welcome, John.
Thanks, Scott. And that's the plan. We will. We have three themes that we want to tell you about this evening. The first has to do with the sounds of water bugs. The second has to do with sounds, very peculiar sounds that we were picking up in shallow water in the summertime. And then finally, Yelena will present a video to us that made last winter, even more bizarre sounds under the ice, especially at Lake Wabamun, west of Edmonton. So I'm going to share my screen now, and we'll get started here. I assume that you're seeing that. No, that's not where I want to be. Oh man, you're going to see all my slides. Okay, there we go. Are you seeing that? Great. Yeah, and you know, I'm going to say as well, right off the top, that this is not a report on finished published research. This is more like field notes. We're still at the discovery stage, and because of that, we're quite excited about these findings. So I look forward, especially to any comments you have when we're all done, and any insights you can share. So yes, let's see. What am I doing wrong? You know, I should have known that something. There we go. I'll just start with a few acknowledgements as well. Rich Palmer in biological sciences here. He got involved with us out on the ice. Murray Gingras has helped this past summer, and my son Jesse, as we refer to Jesse as the engineering department. He's been very helpful with some of these projects as well. And I'd also like to thank the other people listed at the bottom of the screen. Before I forget. Okay, well let's start this story back on the 21st of March, and that was the last day of the winter last year, when we felt comfortable going out on the ice, we kind of felt that the ice was going to get a little soft after that. Jesse and I were out at Chip Lake, about an hour and a half west of here. We had just left Rich and Yelena at Wabamun, and we thought, well, let's see what Chip Lake sounds like. We walked about 100 meters offshore, drilled a hole through 3/4 of a meter of ice, and here's what we heard. Now this is going to be a little faint, so pay close. Oh, that didn't work, did it? There we go. Hold on. I hope you were able to hear that, a very faint sort of tick, 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 tick sound. And right away we thought, oh, that's a Corixidae. And remarkably, I think it is a Corixidae. All through the winter, we thought we were hearing Corixidaes, and really we weren't. We were mistaking things like electronic artifacts and fishing lures, rattling fishing lures. We were mistaking them for Corixidaes, but this one turned out to be a real Corixidae. Let me tell you what a Corixidae is. A Corixidae is a water bug in the family Corixidae. They're also called water boatmen. They have they're delightful little things. I'm sure you've seen them with the long swimming hind legs, and there are quite a few species in this part of the world, but only 3 that we know of that are active in lakes under the ice. So here's Cena Carica Bifida. It has no English name. And we recorded the sounds of this creature later in the spring in an aquarium, and here's what it sounds like. And you have to admit that sounds an awful lot like that sound from Chip Lake. A nice steady, we call it stridulation. They have a file on their foreleg and then a scraper on their cheek, and it's sort of like zick 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 zick, and that's how they make the sound. The sounds, well, we can compare them, and oh, pardon me. Before I do that, I want to tell you that the other obvious candidate in that part of the world is Cena Corixidae, and this one has a slightly different sound. So to us, it sounds agitated. It sounds like an angry underwater squirrel. Here we go. Here, I'll play. This is quite a common water boatman. I'll play a recording from Lac St. Anne in the springtime, and there were a whole bunch of them. Oh, pardon me. Oh, that's not going to. Well, maybe we don't need to hear Lac St. Anne. That the sound of the Chip Lake bug, or the Chip Lake sound, seems to match the first, the Cena Corixidae Bifida, quite well. And if you're accustomed to reading these sonograms, spectrographs, the time axis, the x-axis is the same on both these graphs. So the pulses are coming at about the same rate. There's some echoing, a little bit of muddiness in this recording, but you'll also notice that the dominant frequency in both cases is at about 4 kilohertz. So that's a pretty good match. And we can't think of anything else that might be making those sounds. Now, I don't know about you, but to me, the idea that there can be 3/4 of a meter of ice and winter above the ice, and yet there's insects singing down below, that's really kind of life affirming to me. I was very happy with that, and it's not entirely unknown, but it's, but it's close. Actually, I'll get to that in a second. There's one more potential for the sound maker at Chip Lake, and that's this Corixidae. They all kind of look similar, so you'll have to trust me when I tell you that this species is less common and a little bit bigger, and that's important because even though we caught some later in the spring and kept them in the aquaria, they wouldn't make any sound for us. So we don't know what they sound like, and there are no published accounts of the sound. But we do know that the way they make the sound, the Corixidae in general, is to use the air bubble, the plastron that they carry down with them underwater for breathing. They use that as a resonating chamber. And there was work by a fellow named Tysa, who showed that there's a very nice relationship between body size and frequency. So a larger Corixidae should make a slightly deeper pitched sound. So the fact that we've got those sonograms lining up is really it's pretty good evidence that we've got the right species. I was going to say that the only other work on Corixidae stridulating through the winter and under ice was done by Antti Jansson, the great Corixidae scientist, a Finnish biologist who did his PhD at UBC. When he recorded, he was surprised to hear these things stridulating under the ice in winter. But this is Vancouver we're talking about, where the ice generally melts by lunchtime. So for us to find them under extremely thick ice making sounds was really quite fun. And we do hope to pursue that this coming winter, follow up on it, and see if we can make a little bit more systematic sense of it, if you know what I'm saying. There are lots of other species that appear in the spring, like this one. This one doesn't have any sound producing structures, so it's presumably silent. But these species are not active in the wintertime. In fact, Cymatia americana here, it freezes right into the ice. And that's the safest place you can be in wintertime. There's no way a fish is going to eat you when you're frozen into the ice. And when the ice thaws in the springtime, they just reanimate and off they go. Remarkable. It's kind of interesting. At first we thought, oh, this is great. Maybe you can use a hydrophone, an underwater microphone, to survey for Corixidae using sound, but there's lots of reasons why that might not be the easiest project to undertake. Some species are incapable of calling, as I just said. Most calls are still unknown. Males and females calls might differ, or they do differ. Courtship calls can differ from territorial calls. Different species call at different times of the year, and the calls attenuate very rapidly with distance. So you really can't hear any of these things beyond about a meter when you've got the hydrophone down there. So it's not as easy as it is with birds, or even with grasshoppers and crickets. Although it's still kind of appealing to think that this might be an interesting thing to pursue. But that's all I want to say about the water bugs, because the water bugs are making pretty good sense to us. We're not as baffled by the water bugs as we were when we started out. The next series of sounds I want you to hear about. We've started picking these sounds up, especially in the shallows at Gull Lake, but in many different lakes. And these are summertime sounds, beginning in June. And I'll just play you about a half a minute here. Just listen to this. Oh, where'd it go? Where'd it go? There we are. remarkable. We were completely flummoxed listening to these recordings and played them for anyone who would listen. Various colleagues had various opinions, and for the longest time, we thought that maybe what we were listening to were these little crustaceans called scuds, amphipods, and because the sounds seemed to be coming from near the bases of water plants, and when we got in there with nets and various other sorts of equipment, the only thing we could find were these scuds and the occasional little midge larva, but the scuds, at least they're related to things in salt water that do make sounds, and both Rich and Murray had experience with saltwater sound making amphipods. So, oh yeah, we thought there's got to be scuds. I set up an aquarium. I've got a whole aquarium full of scuds. I put the hydrophone in there. Nothing happens. Our scuds seem to be silent scuds, and they don't have the same sound producing claws that the marine scuds do either. Now, we were really quite perplexed by this whole thing for quite some time, but I'll cut to the chase. Eventually, somewhere in July, my son Jesse, we were out recording one day. This is kind of what I did on my summer vacation, and Jesse noticed that some of these sounds seem to be associated with fine bubble streams. And I'll play you just a little video clip here. I hope you can see. Occasionally, just watch in front of the dark part of the hydrophone, and you'll see these very fine bubble traces coming up from whatever, from below. And I know that's not the world's greatest video, but you get the idea. And so, took the underwater video camera and the hydrophone, tested it out with a number of different sound sources. Yeah, we got the bubble stream every time. Then did some controls with patches where there were no sounds, and we didn't see any bubbles. So we're thinking, well, maybe it has something to do with bubbles. What's making the bubbles? Then I went back to my scud tank, and in the scud tank, this is just a still photo, not a video, but you can see one of these bubble streams coming up. In this case, from this bent and slightly damaged stem, or I guess it's a rhizome of the sago pondweed, and that's the plant that's so common in the shallows at Gull Lake. So we thought, oh well, let's put the hydrophone in, and sure enough, I'll play you the hydrophone recording. It's not identical to the others, but none of the others are identical to each other. There's just such a tremendous variety. So there, it's kind of like an idling dirt bike or something. And that sound is very localized. You get the hydrophone even this far away from it, and it becomes very hard to hear. So we thought, well, it seems to be the plants themselves producing this sound. Now, we have to give credit to our colleague Heather Proctor. It was Heather originally. She said, "Oh, that's got to be the sound of photosynthesis." And I said, "No. And, we thought about that. We looked into the scientific literature, and that's not what photosynthesizing plants sound like." Oh, I should tell you as well that we collected gas samples from both the aquarium plant and from sound source in the lake. Murray Gingras did the analysis, and sure enough, it was oxygen. So yeah, this is plants producing oxygen, and there you go. But here's the basically the most recent paper we could find on the subject, and really almost nothing else, 2018, and these researchers working in saltwater and marine, they say, well, there's a sound that comes from photosynthesizing mats of algae. But listen to their descriptions. The lead researcher, Simon Freya, sounds like fizzing champagne. Well, our recordings were much more exciting than fizzing champagne. The faint but distinctive ping. And then this foreshadowing here, he also says that they were told the sound was from snapping shrimp. End of story. Now, snapping shrimp are marine organisms, and we'll come back to those when Yelena's turn comes. So amazingly enough, I mean, that's all I can find on the sound of photosynthesizing plants underwater. Our plants are so ridiculously noisy compared to this. It seems unlikely that no one has heard this before, but I think that's the case. Remarkable. So we none of us are botanists, so we don't really know where to go from here. But hopefully, we can get some interest from someone who might be able to relate this to plant physiology in a more rigorous way. Here's another relevant paper describing a cacophony of undescribed biological sounds, and then they interpret these sounds as communication among organisms underwater, and then they suggest that the sounds that are produced by people, by boats and such especially, might be threatening this communication. They describe it as a diverse array of unidentified biological sounds. Well, that's familiar. That's what we've got too. But then they say some of the most common sounds appear to be of the little understood air passage type. And by air passage, they mean the movement of air within the bodies of fishes. So, basically burps and gurgles and flatulence and the movement of air to and from the swim bladder, the buoyancy organ inside a fish. And then this common sound that they refer to, it's kind of a joke, right? FRT, the fast repetitive tick, a broadband high frequency burst followed by a train of repeating ticks. Well, we have all sorts of recordings of these plants that qualify as trains of repeating ticks. So we're wondering if perhaps we've got a better candidate for these unidentified sounds than fish air movement. But again, this is early stages. It's very exciting to consider this possibility. And of course, if it is, if these are all plant sounds, well, then presumably they're not troubled by the sounds of motorboats. But who am I to say on behalf of plants? Amazingly, when I told the story and played some recordings at the store where I get my aquarium supplies, they said, "Oh yeah, aquarists know all about this. We call it purling when you have the water in the aquarium saturated with dissolved oxygen, then and especially when there's a lot of carbon dioxide in the water, and aquarists often enhance the carbon dioxide in the water. You get these bubbles forming on the plants, and on the left picture here is very much like what they describe in that mat of algae situation. And on the right, well, there's a bubble stream very much like the bubble streams we were recording. So it's that's encouraging. It's a little bit just strange that it's easier to find part of the answer on Twitter and Reddit than it is in the scientific literature, but there you go. And at least the aquarists don't know what they sound like. So isn't that interesting? I hope you find that interesting, and I hope that we can either pursue this further or convince someone with more knowledge of plants to take it the next stage down the research line. Now, what does this all mean? Well, the marine biologist suggested that perhaps you could use the sounds of photosynthesis to monitor photosynthesis. Maybe this is some kind of an environmental monitoring technique in the work. So that's an exciting possibility. It's also from the point of view of someone who is interested in the biology of animals. you've got to think that anything that has a sense of hearing living in these environments, this is the soundscape in which they have to operate, in which they have to listen for each other, listen for prey, listen for predators. And that could include any number of different fish with a sense of hearing, the Corixidae themselves, and even perhaps things like shorebirds, which have very sensitive bills when they're probing into the muck and the water. The bill is very sensitive, and they must pick up on those whines and squeals and sirens that we were recording. So that's kind of interesting as well. All right. Well, I've hopefully kept within my time limit because I want to leave space for Yelena's video. So those are my progress reports, my initial reports on those two aspects. And now I'll turn it over to Yelena to introduce her video.
Thanks, John, and thank you everyone for coming tonight. My name is Yelena. I'm an undergraduate student from the U of A. I graduated from the Environmental and Conservation Sciences program, and I majored in land reclamation. So I initially met John while taking one of his courses. It was called Parks, Ecology, and Society. And we kind of bonded over our mutual interest in the soundscape of different environments. So we started to go on these nature walks for the purpose of listening to the sounds of the environment and recording them while discussing kind of different elements of soundscape ecology. Sure enough, the following semester, I ended up joining a directed studies course with him in soundscape ecology as well. And that's where this video came from. So I decided that I wanted the final project to be audio-visual in nature. So I decided to do a video instead of writing a paper or using a more traditional project format, because John and I both felt that the acoustic elements of an environment are often underappreciated or sometimes even unnoticed. And this was a really effective way to emphasize how interesting an approach it could be, while allowing me to really incorporate the sounds we recorded heavily into the project. I also really wanted to instill an appreciation for learning about different environments through sound, but also instill an appreciation for the beauty that can be held in this. So this project focuses mostly on a mystery that, as of now, still remains unsolved, but I don't want to spoil too much, and the video is 25 minutes long, so I'm going to keep this short and sweet.
Imagine yourself visiting a city park. What wildlife is present? Are there other park visitors? Chances are you're imagining what you're likely to see. Human beings are particularly visual creatures. This is primarily how we experience life. Imagine paying attention not to the landscape, but to the soundscape. Imagine closing your eyes and listening. What more can we learn by using another sense to understand our environment? You are likely to hear anthropophony, sounds with a human origin, like traffic, machinery, maybe distant music. You are likely to hear geophony, natural sounds created by the environment but not from a biological origin, like wind, the flow of water, ice cracking as the temperature drops. And finally, you'll hear biophony, sounds made by living organisms, bird calls, squirrels chattering. This is the focus of a relatively new field called soundscape ecology, in which we study sound as an integral component to any ecosystem. For the most part, ecology has focused more so on the landscape, or the visual elements of an ecosystem, rather than the acoustic. After spending some time listening to the winter soundscape, I began to wonder, what might we learn if we were to listen to the underwater winter soundscape? Studying the acoustic components of other ecosystems has led us to a deeper understanding of species and environments, but also how they can be affected by anthropophony. One study found that traffic noise, in absence of an actual road, was enough to reduce bird abundance by a quarter. They called this the phantom road effect, but there are other instances of anthropophony affecting wildlife. There's even evidence to suggest that some species can take advantage of anthropophony, using the noise to mask their activities and evading predation. This is known as the acoustic refuge hypothesis. I began to make frequent trips out to Wabamun Lake, about an hour west of the city of Edmonton, along with my supervisor John Acorn, Jesse Acorn, an electrical engineer, and Dr. Richard Palmer, professor emeritus. Under a layer of ice a meter thick, the underwater environment of the lake was as foreign and mysterious as it gets. The under-ice soundscape is fascinating. It's characterized by booms and cracks and creaks, sounds of the ice itself, expanding and contracting with changes in temperature. You can hear these sounds pick up on windier days. Anthropophony can travel extremely far underwater, especially lower frequencies. There are many times we heard footsteps or auguring underwater even when we couldn't see anyone else out on the ice with us. As interesting as this all was to me, I couldn't help but wonder if I would hear any evidence of the life I knew was there somewhere. And it turns out I wasn't the only one.
So I became interested in the general question of whether there was any sort of animal sound under the ice. I mean, the soundscape is so interesting, but is any of it being made by animals?
John's search for under-ice biophony took him on multiple trips to multiple lakes to hear burbot, a fish known to make underwater sound. Despite going to Lac Sainte-Anne, a lake known for its burbot, with an expert fisherman, the burbot sounds remained elusive. There's also a kind of water bug called water boatmen or Corixidae that makes stridulation sounds underwater. They do this by rubbing their legs, which have a row of pegs, along their cheeks, using the air bubble surrounding their body as a resonating chamber. At one point, we were quite sure we were hearing these stridulations under the ice, but when John heard the sounds in an otherwise empty bucket of water, we realized that what we were hearing was actually an electronic artifact from our recording equipment. We never did end up hearing any burbot on any of our trips out, despite hearing that ice fishermen were catching plenty of them in Wabamun Lake. Between this and mistaking an electronic artifact for Corixidae stridulations, we could have been easily discouraged. But instead, we were more determined than ever to hear evidence of life under the ice.
This is actually a really cool story. We're going to be joined by Professor Richard Palmer, and he's got a couple of things that he's working on, but he will tell us a story about one thing that he's working on about Alberta lakes, and there's this popping noise going on in Alberta lakes, and what is behind the popping noise? You're going to have to stick around to find out.
A colleague of mine, John Acorn, who's better known as the Nature Nut, and I are out putting hydrophones or underwater microphones under the ice because we hear some popping sounds in Alberta lakes. And we don't know what makes them. It could be an ice artifact, or it could be some creature that we don't know yet that has this ability. And we need to amplify the sound a lot, so they're not super loud, and we have to stand absolutely still because any movement creates sound. But if we don't have distracting surface sounds, there's this very distinctive popping noise that only occurs in certain areas. For example, in Lake Wabamun. In fact, we're probably going to head out there this weekend.
So, yeah, it was 2012, not far from here at Whitewood Sands. And we were hearing that snappy poppy sound, and I didn't know what it was. It was a nice warm day like today, and so I just assumed it had something to do with the snow melting on top of the ice or something. I just made up some explanation that made sense to me at the time. It was 8 years later. I was listening to recordings of the marine snapping shrimp online, and I thought, well, wait a minute. That sounds a little bit like that recording from Wabamun, because I've never heard this sound in any other lake. And so I sent the Wabamun recording to Rich Palmer, I said, Rich, is there any possible chance this is cavitation produced by some organism? And that's when Rich became interested. So yeah, it took a fair amount of time to clue into the fact that there was something worth studying here.
In marine animals, the most familiar ones and well-known are snapping shrimp, because they jet water extremely fast with their claws, and those jets of water move so fast that they create a vacuum behind them. It's called a cavitation bubble, and just the ambient water pressure causes the sides of that bubble to collapse. And when the sides come together is when you get this incredibly loud snapping sound.
Do we have any non-marine animals that can do that, like in lake ecosystems? Or
this would be a first, as to my knowledge. The only animals that are known to make cavitation bubbles are in the sea. Is it an animal that lives on the bottom? Is it an animal that lives in mid-water? Are they more common close to shore, offshore? And once you narrow down some of those things, then you can start to focus your sampling to maybe try to collect them and figure out what they are. Whoa! And there's a backskid.
Oh, is there?
Yeah.
Oh, great. Oh, it's a water boatman.
A water boatman.
That corrects it. Fantastic.
with John's pop bottle trap and a glow stick lure, we were able to capture small crustaceans Diaptomus and Daphnia, and Corixidae, or water boatmen.
11:31, and it's 21, and we'll get a depth once we pull it out here.
It's very sensitive to any noise from the feet on the...
Oh yeah, you can't shuffle at all.
Okay.
Just as we'd hoped, the mysterious sound was still present. We began referring to the sound source as snapper poppers, even though we still didn't know for sure if some creature was in fact the origin. Despite the frigid January temperatures, we were eager to return just to get to the bottom of it. We couldn't let ourselves get too excited just yet, though. It can be extremely difficult to relate an underwater sound to its source. We returned to Wabamun Lake the following week, but this time we would record at 3 different beaches. First up was Moonlight Bay. The goal was to figure out whether the snapping popping could be heard at more than one location on the lake. We figured that if it was an ice artifact, we'd be able to hear it anywhere.
Moonlight Bay's got a very narrow opening, and it's connected to the main part of the lake. But because it's such a narrow opening to that lake, if we put the hydrophone down in Moonlight Bay and we didn't hear anything, that would suggest that it wasn't being confounded by ice sounds coming from the whole lake.
We were confused to find that Moonlight Bay was relatively quiet, aside from some background noise and a quiet, bubbling-like sound. The Seba Beach recordings seemingly yielded the same results as the Moonlight Bay recordings. They were quiet, aside from some ice cracks and other obvious ice artifacts.
But the reason why it's actually exciting to record here is that the other 2 places we've been today, Moonlight Bay and Seba Beach, we've heard nothing. And so this is the definitive test about whether the sounds that are being made are, well, it's not a definitive test, but it would be a very positive test that the sounds are being made by some creature, because there's something unusual about this spot if we hear it. If we don't hear it, project over.
One interesting thing is that the low frequencies, we hear those when the ice cracks in a very noticeable way. When we have a big ice crack, then when we hear, we look at the spectrogram and there's something in the low end. But the interesting thing about the snap and crackle pop sounds is that they don't have much below, say, 1 kilohertz, which maybe suggests that they're produced by something very small-bodied.
Right.
I don't know.
Okay, well, moment of truth.
8 snowmobiles? Give me a break.
At our third and final location of the day, we finally did hear the snapping and popping we were hoping for. To hear it at only one of 3 locations, all visited on the same day, led us to believe that this really could be a creature, and not just an artifact of the ice. This trip, we returned to find the Wabamun Lake underwater soundscape noisier than ever.
Whoa! That's something else altogether. But there's still the background popping. Absolutely.
So we have crackle pop sounds, and we have all these little week sounds that are kind of, they're just sort of bubble noises, I think. But I don't know where they're coming from, and I don't think we've heard them before.
Well, that's exciting.
But
we do have the crackles, though.
Yeah, we do.
Oh man, that's excellent news. Because yesterday at Lake Isle was crackle free.
So what have we found so far? A lot of bubbling near shore, which is totally different and could actually make it hard for us to extract data. But certainly at our mid-distance site here, about 100 meters offshore, it's really quite amazing. I'm actually thrilled to hear as much crackling as we do. More and more this is sounding less like an ice artifact and more like some kind of creatures. Our far offshore one is going to be a fun one to check. If we're lucky and it's consistent with the last pattern, it should be quite a bit quieter offshore. And I think if we hear that, that really strengthens the idea that there's some creatures under the ice surface here. So good start to the day.
We returned the next day to retrieve some traps and decided to have a listen as well.
It's quiet.
It's quiet, really. It's quiet today.
Yeah, no crackle popping. A few of the bubbly ice cracks.
It's quiet today. This place is so mystifying.
You know, I think all of us vacillate. You know, one minute we're pretty sure that this is a sound made by a living organism or lots of living organisms. And the next minute we're pretty sure that it's made by the ice, and then we remember that not all lakes make this sound. In fact, this is the only lake we know that makes this sound. Maybe it has to do with springs or groundwater or plumbing or the railroad, and at the end of the day, I have no idea.
And the thinking goes, anyhow, that we take a couple of gallons of hot water supplemented with boiling water here. And the theory is after we dump the hot water down, it'll be less dense than the surrounding very cold lake water, and it'll spread out right underneath the bottom of the ice and create, for a few minutes anyhow, a really abrupt thermal difference. If the sounds go up spectacularly 5 or 10-fold, that strongly hints that it's something to do with tiny little cracking right at the ice-water interface. If there's no change at all, it leaves open the snapper-popper creature hypothesis.
Well, if there was an increase in the snapper popper sounds, then it wasn't dramatic. It may be statistically useful, but yeah, I didn't notice that much of a change with the hot water.
Once again, we left with more questions than we arrived with. We couldn't definitively interpret the results of our hot water experiment. In fact, soon, Rich would realize that we barely used enough hot water to fill the ice hole, and we'd need even more to be sure that it would spread under the surface of the ice. We decided to conduct one more hot water experiment, but this time with twice as much hot water. This is what we heard before pouring in the hot water. And after. It may not sound very dramatic, but Rich's analyses showed that adding the hot water had a dramatic effect on the snapper pops. They increased significantly after its addition and gradually decayed over time. The final hot water experiment had almost definitively refused the snapper popper creature hypothesis, but we returned for one last experiment anyway. We decided to test whether the vertical orientation of the hydrophone made any difference to what we were hearing. We also wanted to use 2 hydrophones to see if there were any small differences between the arrival times of the snaps.
Oh, it's almost as good as the hot water experiment.
It's really good. It's really good. It's a concert down there today.
Whoa. We should, oh man, there's some loud ones.
It's What do you think?
There's a lot going on.
This is like the Wabamun Symphony Orchestra.
We found that the snaps and pops were coming from a distance as opposed to coming from something small near the hydrophones. We stood silently to listen one final time for the winter. It had become almost meditative, a weekend ritual to listen intently to the under ice soundscape. The hydrophone's orientation didn't seem to affect what we were hearing, but that was only half the reason for a return that Sunday. The other reason was because we simply enjoyed it.
For me, the really exciting thing that happened this winter was to figure out that just under the ice, even in the middle of winter, even at very cold temperatures, there is an interesting little assemblage of critters. There are crustaceans, planktonic crustaceans such as Daphnia and Diaptomus, and there are Corixidae bugs, water boatmen, feeding on those crustaceans. The only one that we've been able to confirm is Corixidae, but there you go. Why does this lake have the snapper popper sound? That we don't know. We have some ideas. Maybe it's just something to do with the ice. Maybe it's, maybe it's not.
But actually, the thing probably most interesting to me has been getting some of these recordings of ice cracking noises that are really remarkable, especially some of the, well, I mean, the whole project has taken us to more lakes than just Wabamun, and especially at, I think it was Lake Isle, we had some incredible cracks that I might use for some semi-musical purpose or something, I don't know. But also it's indicated just how much the ice can function kind of like a reverberating plate. It almost makes me want to try doing something with ice as a source of reverberation.
Well, so we're just about 2 months into this project, having started the end of January, and one might ask, was that 2 months worth it? Because we've made how many trips out over those 2 months? And as far as I'm concerned, it's been quite quite wonderful, because the puzzle that got us interested at the beginning, it's maybe not completely solved now, but it was certainly a worthwhile puzzle to try to solve. The puzzle is that the really loud snapping, popping sounds that we hear, that were in all their glory today, seem to be unique or nearly unique to this lake. And that's a tricky thing to explain. Over the 2 months of listening, what are the kind of definitive answers we've come to? And I guess there aren't any really definitive ones, but certainly that the hot water experiment, dumping that large volume of hot water and getting a sudden pulse in sounds very similar to the normal snapper popper sounds we get, that's pretty close to definitive, that the source is something to do with ice deformation and cracking.
Do you think there would be any value to try a hydrophone recording in the summer?
Absolutely, yeah. Oh yeah, sure. And the trick is that you have to do that from a boat, unless you have extremely large sandals, which by my calculation in my animal structure and function course are about 1 kilometer in diameter. So water striders walk on the water surface, and humans could too, but they would need sandals that are about 1 kilometer in diameter. But sure, I think that would be worthwhile doing, because that would, if you heard it in the summer or when there's no ice, I'd be back.
After spending the winter outside recording under the ice, there's a lot we've learned. We know that anthropophony can travel great distances underwater before reaching attenuation. We know that for some reason, Wabamun Lake has a curious snapping-popping component to its soundscape. Of course, we still have a lot of unanswered questions. What is the cause of the snapping-popping sounds, if not a creature? If it is the ice making this sound, how does it happen? So now it's June, and I'm back at Fallis, and today it's going to be plus 30 instead of minus 30, like when we started out coming here. So far this summer, we haven't heard any of the snapper poppers, but we are hearing Corixidae stridulating under the water, and we think we might have some of our winter recordings with the same sound. So we're just working on finding out which species we might have heard over the winter, if any. And as for the snapper poppers, it's still a mystery. We think it's probably some artifact of the ice, but we're not really sure about that. So we'll probably be back out next winter to investigate it further. And I can't believe I'm saying this in Alberta, but I'm actually looking forward to it.
Hi, everyone. Wow, that was a real whodunit. I didn't expect it was really going to be that much of a mystery, and it's still unsolved. Oh my goodness! But that was really, really fun. So thank you both for this really fun, strange talk. I'm so looking forward to hearing answers to questions, which I'm sure folks have. So what we'll do now is, I know that we're right at time, and some people may have to go, but I would like to go ahead and go over 8 o'clock and just have a few questions. I see, let's see, I see a question from Marisol. I hope I pronounced that correctly.
Hi, thank you. Super interesting talk. Yeah, I was wondering, what are the next steps now? What are you guys planning? I'm super curious.
You know, very good question, Marisol. And you know, I want to remind everyone here that this was, you know, Yelena's project started as a directed studies course, which of course had no budget. You know, this is my own personal equipment and so on. So the next step is exactly this: is to generate some sort of interest and see who might want to pick up on these these new sounds and do something with them. So yeah, we're very interested to hear people's responses.
One chat question, which I also find an interesting question, is this question about the possibility of triangulation. Now, I imagine, given the smallness of the sound, I mean, you said that the hydrophone was really getting close into things. I imagine triangulation might be a few inches on either side in order to be able to actually do that. But I don't know. I mean, how sensitive, how far away do we have to be able to do that? Is that a possibility?
The problem with triangulation, and that would be a really obvious thing to do with the snapper popper sounds. I'd have to buy a third hydrophone, right? You need 3 corners for a triangle. So I only have 2. So yeah, maybe that's one of the next steps is to, but we did one test with 2 hydrophones. What was it, Yelena? Was it 5 meters apart?
Yeah, it was 5 meters apart. Yes.
Yeah, and we were able to measure the difference in milliseconds of a snap arriving at each one, and determined that it was coming from somewhere toward the shore, and that we were it was traveling at about the speed you'd expect if it was in line with the 2 hydrophones.
Great. Let's see. What we have next is Aaron Bain. Please go ahead.
So John, Yelena, very cool stuff. I mean, my actual question was kind of going to go to the same thing about triangulation and understanding, obviously, the cost of the hydrophone. But John, how did you come up with the conclusion that you were only hearing up to a meter? And I mean, the reason I ask is like your frequency range is actually, I mean, in a place that, that sound's going to travel reasonably far at, 4,000 hertz or whatever. So, I mean, obviously the amplitude is not very high, but how did you figure out or estimate that it was a meter?
Actually, with the Corixidae, oftentimes, you can see you can actually look at the bug that's making the sound and move it. I think what's happening in the very shallow water, where you can see what you're doing, and that meter, that's in the shallow water, is that the sandy bottoms that we're working with are real sound absorbing surfaces. So you may have the sound reflecting off the surface tension and back down, but it's being absorbed a lot too. So it's not just a matter of the amplitude is relatively low, but you've also got all this absorption as well. Yeah.
Because one thing, I mean, I was just thinking about it. I will send you a paper that one of my postdocs did, and he actually used a 3D printer to set up an array of 4 microphones really tight, and that would probably be able to get you better localization, maybe cheaper than you think with microphone combinations. But anyway, we could talk about that more at some other point. But I think that would be cool. Have you ever, though, as well, I know your equipment's too expensive, but have you ever left it out for a long period of time and then tried to track what temporal change might look like? Because I would think that would really help you. If you looked at when the sun was coming up or going down and what the conditions, temperature was, you might be able to make some more conclusions about the ice. Do you have any longer term recordings?
That's a good idea. No, we don't. Of course, in the wintertime, what you worry about is the cord freezing into the ice
and water, right? Yeah.
Then you got to buy a new hydrophone right then.
Another thing that was kind of an issue with that was that our batteries kept dying just because of the cold temperatures. So I would be worried about just the battery lasting long enough, unfortunately.
Yeah, you'd have to.
Yeah, it would be interesting. I mean, the other thing I was just going to go is like, if in the future, for reference, I mean, they do make hydrophones for like the cheap ARUs that I use, which are a lot less expensive than yours, and are somewhat more sacrificial. So, I mean, that'd be something to think about. Is depending on the quality that you need. I was just going to go with there might be the possibility of doing that kind of stuff because they do exist. So.
Yeah, I'd love to talk to you about it, Aaron. I'm sure Yelena would too. Yeah.
Cool. Neat stuff. Thanks.
See, we're already making connections here in Sound Studies Institute. Sorry, I'm just kidding. Of course. So let's see. We have now Matthew that has a question.
Yeah, I thought I'd hold this until everybody else looked like they were done and we were on the verge. So bearing in mind that I'm watching from Phoenix, what's ice?
It's a remarkable substance, Matt, and if I can relate that question back to Aaron's, of course, under a meter of ice, you've also got very different water than what we're experiencing in the shallows too, with a lot more pressure, and the ice itself is a reflective surface. It's a crazy world down there. While you're, and I don't mean to cut you off, Matt, if you got more to say or ask, but I do want to point out that I purposely put the term baffled in the title of this talk for Matt's benefit, because Matt and I, years ago, we were commenting to each other about how often journalists use the term baffled in science news stories. Scientists baffled by this, scientists baffled by that. So we started a Facebook page called Things That Baffle Scientists. I encourage you to check it out.
I'm going to ask a quick question. I was reminded of this question when I think actually I just have to say one of my favorite things about the video is that you let us see the problem of the snowmobiles, and then you let us hear it from the point of view of the hydrophone, and that was really fantastic. And it's just as in terms of like the process of doing all of this. And what I was wondering about is, in all seriousness, when you are trying to record in a lake in the summer, now I have only a tiniest minute amount of experience with hydrophones, but one thing I do remember is once trying to record some snapping shrimp and just being constantly inundated by the sounds of very loud motors. And I would look up and take my headphones off, and I would see a boat about a kilometer or two away. But it's like, I mean, of course, and it makes sense. Sound travels more efficiently and all that through water. So I'm just curious about what kind of strategies you have to undertake in order to get, a good length of recording in the summertime in particular. I mean, I guess in the winter, the snowmobiles would probably be the only. I don't know. Maybe there would be some other problems too. But
winter's terrible. You tell them about the winter problems we had, Yelena.
Oh my goodness. Everything from ice augering, you couldn't even see other people on the ice, but you could hear them augering for ice fishing. Lots of snowmobiles, those were really noisy. Vehicles driving across the ice as well. Even just like you could hear footsteps. You couldn't see other people on the ice, but you could hear the footsteps through the hydrophone. It was really, really incredible.
And in contrast, in those very shallow situations in Gull Lake in the summertime, there could be water ski boats in plain view, maybe half a kilometer away, and you barely hear it in the hydrophone because those shallows and all that sand, it just soaks it up. It's like acoustic tiling. It's marvelous.
Would anyone else have questions? I do see Donna has a question about water temperature, it being a factor in the soundscape, and how the water temperature she observes when it's much warmer, how that might affect things. I guess you kind of talked a little bit about that in terms of pouring the hot water in order to sort of disturb the ice surface and see if that's where you are actually getting the sounds from.
Yeah, we did find that we could kind of induce the snapping and popping sounds, at least at Wabamun Lake, by increasing the water temperature just under the ice surface. I'd be curious to try that at another lake to see if we can induce the same sort of thing. Because if we can't induce that at another lake, I'm inclined to say that temperature wouldn't be the only factor. But yeah, I mean, it certainly could be. It's something that we've considered as a possibility, and we'd like to look into more.
Yeah, I'll just add to Donna's point that the power plant that what it used to empty into Lake Wabamun no longer does. That one's gone. So Wabamun should, in the wintertime, in theory at least, the deepest water should be the warmest 4-degree water, and it should grade all the way up to near zero right under the ice. So at least those winter temperatures are very stable.
So thanks everyone again for coming tonight. And I wanted to just also remind you that we do have these talks every couple weeks on Wednesday nights at 7 p.m. And if you want to know more about the lecture series, you can visit our website. I encourage you to visit the site over the next few days as we get the descriptions up there, or just show up every couple weeks and we'll be here. So thanks again for coming, and thanks to John and Yelena. One more time, let's unmute ourselves and create a weird sort of, what do we call it? Like, does it sound anything like the underwater sounds? Is it working? I don't know, like popping, snapping shrimp, weird bugs, plants. I don't know what that sounded like, but anyway, thanks again, everyone. This has been really fun, and we will see you hopefully in 2 weeks.
Thank you.
Thanks so much.